Number one, so the first thing we're going to do is differences of squares. The things you have to know, and this is going to sound very repetitive to the video today that you guys have posted to take as notes. But one, it has to be different. So it has to be subtraction. I'll move my paper down just 1 minute. So it has to be subtraction. It has to be a binomial, which hopefully we know at this point means two terms. And they have to be perfect squares. And by perfect squares, I mean like the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So it has to give you whole numbers when you take the square root. The square root of x squared is x. Because remember, when you're taking the square root, you're asking what number can I multiply times itself twice to get out wherever we started. That's the square root. So it's the inverse of squaring something like we've talked about. So as soon as you check it, so we want to make sure it's minus, we make sure it's a binomial, make sure it's an x squared, and that the other number is available to take the square root of. As soon as you see that, you can open up two sets of parentheses. You need a plus and a minus. And the reason you have a plus and a minus is because every time you take the square root of any number, there's always two answers. Anytime you've used it prior to now, if you haven't written down two numbers or discussed two numbers, it's because one of them is not applicable. So like in distance, the negative number doesn't, or Pythagorean theorem, the length of a triangle doesn't really pertain to the conversation. So it's not heavily discussed. But algebraically, every time you take a square root, you have a positive and a negative. So we're going to take our n squared. We're going to take the square root of that, which means it's n times n. So we're going to put an n in the front of both sets of parentheses. And then the second one is a 16. So we're going to take the square root of 16, which is 4 times 4. You're going to put a 4 in the first one and a 4 in the second one. You have now factored by difference of squares. So this is factored. Only factored. If it's said to solve, what are the solutions? What are the zero? What are the x-intercepts? Roots. That is all where we have to set these two factors equal to 0 and then continue to solve. So x plus 4 equals 0. And x minus 4 equals 0. Or in this case, n, I'm sorry. So minus 4 from both sides. So n equals a negative 4. And then add 4 because that's the inverse of that negative. So x equals 4. So it's a negative 4 and a positive 4 are our solutions, x-intercepts, roots, zeros, for n squared minus 16. So this is now solved. So if it says solve it, you got to go all the way to the 0 part. You have to factor to solve first, then keep going. To factor, you can stop right there where you have your parentheses. So number 9 looks a little different because there's a number in the front. When there is a number in the front, you always, always, always want to think GCF first. So GCF is your first thought for all things factoring and basically all things at this point quadratic. So anything that has an x squared. You want to see if there's anything I can pull out. So 9 and 25. Do 9 and 25 have any number in common? So 9 is 9 and 1, 3 and 3, and that's it. 25 is not divisible by 9 or 3, so it does not have a GCF. 1 doesn't really count because pulling out a 1 changes nothing. It just leaves it pretty much exactly the same. So we know GCF is off the table. It is a binomial. I know I can take the square root of 9. I know I can take the square root of 25, and it is a quadratic, so raise to the second power. So I can open up two sets of parentheses, a plus and a minus, and it doesn't matter if you put the minus first or the plus first, either way. We're going to take the square root of 9, which is 3 times 3, so we're going to put a 3 and a 3. The square root of n squared, and that's going to be n times n, so that n goes in the front. So 3n is the square root of 9n squared. And that just broke it into two different conversations, so you see that you're doing both. Then we're going to take the square root of 25, just 5 times 5. So we're going to put a 5 in the first one, 5 in the second one. You have now factored completely, so this is the factored form, by differences of squares. To solve, we're going to set them both equal to 0. So 3n plus 5 equals 0. Move that 5. How am I going to move that 5? Add it, subtract it, multiply, or divide. Type into the chat box for me. How am I going to move that 5? What operation am I going to use? Yes, sir. Thank you. So minus 5, minus 5. So 3n equals a negative 5. All right, somebody else, different. I'll start calling out personal names. So how do I get the 3 off the n? Actually, let's back up. How is 3 attached to the n? What operation is 3n illustrating? And that would be like multiplication, division, adding, or subtracting. What operation is 3n illustrating? Yep. All right, y'all gonna make me call out your names, huh? Okay, I can do that. Thank you, Joseph. So the inverse of multiplication. What is the inverse of multiplication, Miguel? What's the inverse or opposite operation to multiplication, Miguel? Miguel or Jakaya? One of you guys save us here. What's the opposite of, yeah, good job. So we're going to divide by 3. So n equals a negative 5 over 3. So that's the first one. Now we need to do it for 3. N minus 5 equals 0. How about, Jakaya, tell me how I'm going to move that negative 5 to the other side of the equal marks. It's a negative 5, so the inverse of the minus is going to be what? How are we going to move that 5 to the right side of the equal marks? Taquan, can you tell me how to move that 5 to the right-hand side of the equal marks? We're going to move it to the opposite side across the equal marks. Jakaya, Taquan. Emma Taylor, anybody tell me? How do I move the 5 to the right-hand side of the equal marks? Thank you. You are the bomb. I appreciate that, Emma. So plus 5, so 3n equals 5. All right, Jakaya, Taquan, you guys have a rally. How do I get 3 off of n? How am I going to get rid of that 3? Add, subtract, divide, or multiply? Cadence, come in there and save me. How am I going to get that 3 off that n? Thank you, Abby. Divide by 3, divide by 3. So n equals 5 over 3. So our solution set is going to be that negative 5 over 3 and 5 over 3. And that's listed. Those squiggles mean it's a list. You will also see it written as plus minus 5 over 3. Not 3 over 5. 5 over 3. So plus minus 5 over 3. So we'll do 2 more at least. Number 3. So it is a binomial, it is an n squared, and it is a subtraction. So that means a is 1 in the front, so we're going to get straight after differences of squares. So 2 sets of parentheses plus minus. So the square root of n squared. Can anybody tell me what the square root of n squared is? Yep. So let me don't put an n in the front, n in the front. Excellent. We'll take the square root of 4. Somebody tell what the square root of 4 is. 2. Yep. Square root is the opposite. So the square root is not squaring. It's finding out what number did I multiply to get 4. So that's going to be 2 times 2. So we're going to put a 2 in the first one and a 2 in the second one. So again, this is the factored form of n squared minus 4. Solving. So I have n plus 2 equals 0 and n minus 2 equals 0. Somebody tell me what my 2 solutions are. If I have n plus 2 equals 0, I'm going to solve for n, and n minus 2 equals 0, solve for n. Or if you can tell me what one of them is, that's great. Jakaya, Taquan, come on, guys. Give me something. Please don't let me think you just got this, jumped in and then walked away from the computer. Taylor. Cadence. N plus 2 equals 0. If I solve it, what do I get? Close. So I need to leave the n by here. I'm going to subtract 2 from both sides. So n equals negative 2. This negative 2, we're going to move it across. So n equals, we're going to add 2 to both sides. So n equals positive 2. So -2, +2. Remember that n and the 2 are separate. So we have to get n by itself. In many of our lab classes, I've talked about where you box in the n and then move whatever's attached to it just so we can get there. So as a solution set is -2, 2. Again, you could also see it ±2 written that way because that means a positive and a -2. All right, we're going to do one more. So number 4, it is a binomial. That's 2 terms. I can take the square root of 25. I can take the square root of 1 because 1 times 1 is 1. There's not a GCF, so I'm just going to open up 2 sets of parentheses. I put a plus and I put a minus. So we're going to take 25x squared and we're going to take that square root. And you can break it up separate. So square root of 25 and the square root of x squared. Who can tell me what the square root of 25 is? Yes, sir. So there's going to definitely be a 5 in the front. 5 in the front. Who can tell me what the square root of x squared is? So what did I multiply? Yes, good job. Thank you, Cadence. Thank you, Joseph. So 5x. Then we're going to do the square root of 1. The square root of 1. What did I multiply times? Yeah, good, good, good. 1, 1. So again, we now have our factored form. We're going to take these and solve them. So 5x plus 1 equals 0. 5x minus 1 equals 0. All right, Taylor, Jakaya, this first one. I'm going to box in my 5x. I'm going to move this 1 over. How am I going to move that 1? Addition, subtraction, multiplication, or division? So Jakaya, 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 or Taylor, Taylor, Taylor. Talk to me and tell me how to move that 1. Subtract, multiply, divide, add. Thank you, Joseph. Jakaya, Taylor, you let me down, my friends. I'm trying to say it loud for those in the back in case you were away from the computer. This is very important. If you do not learn how to do this, you will have a very hard time on your EOC. Very, very hard time. And in your future math classes. That's why we're here, guys. So we're going to subtract 1. So 5x equals -1. We're going to divide by 5 on both sides. So x equals a -1/5. 5x. We're going to move that -1 by adding 1. So 5x equals 1. Divide by 5 because that's the inverse of multiplication, and x equals 1/5. So our solution set is a -1/5 and 1/5, or can be written as plus or minus 1/5. Does anybody have any questions on the differences of squares, or is that enough? You're going to see some more today, and let us get into the factoring trinomials. Okay, good, awesome. Miguel, Taquan, Cadence, Abby, Emma, how are you guys feeling on these? Do you want me to do 2 more or 1 more, or can we move on to the next thing? Do you see the pattern pretty well? All right, cool, cool, cool. All right, beautiful. So this is where it gets weird, but not super weird. Not super, super weird, as long as you're staying invested and you're paying attention. It's not terrible. It's just different. So here's what we're going to do. You'll see it if you were to Google more videos on it. They call it all different things. I call it big star. I've seen them call it asterisk. I've also seen them call it snowflake. So remember, this is a, and I'm just using x squared plus bx plus c when it's a trinomial like this. So where we use this form, it has to be a trinomial. So that's 3 terms. A times c is going to go at the top. B is going to go at the bottom, which is not much different than our regular diamond. A times x and a times x go in both upper corners. The lower corners are going to be our factors, just like we filled in our diamond. So looking at this equation, what is our a value? What is the number that is a? Only a number, so don't worry about the variable. What number is a? Yes. What number is b? Good job, guys. Yes, 27. Awesome. And c? Yes, good job. Yeah, 70. All right, so a times c, so that's 2 times 70 is going to give me 140. Our b value you just told me is 27. Our a value is 2, so we're going to be 2x, 2x. And I said it in the video today that you're going to do for practice and for our notes. You should be able to get at least that much done without any major issues, because that we can memorize. And if you just practice doing that much on day 1, trust me, in a couple of days, this will be super stinking easy, okay? So now I need to know, what did I multiply together to get 140 to add or subtract to give me 27? Now, I don't know all the factors of 140 off the top of my head. So if I take 140 divided by x in my calculator, and you can also do this in Desmos, I can hit second graph, and I see 2 and 70. That'll be 72 or 68. 4 and 35 will be 39 or 31 if I added them or subtracted them. 5 and 28 is going to be 23 or 33. And then I have 20 and 7. So 20 and 7 are going to be our best deal, because 10 and 14 will give me 28 again. And then after that, we're going to wrap back around, I believe, to 10 and 14. So we've already got there. So it's going to be 20 and 7. I always put the biggest one on the left-hand side, like in order from largest to smallest. But you can put them on either side. It does not matter. I have a positive 27 and a positive 140. So we're going to keep both of these positive. Now, here's the weird part that not every math teacher loves. But in my mind, it makes total sense, because we have been reducing fractions since we were back in middle school. So reducing fractions. But hear me out. This is not a fraction. We are just cheating the system and pretending like it's a fraction. So can 2 over 20 be reduced? Do they have a common factor? 2 and 20 are both divisible by 2. Don't lose your x, because it's still there. Yep, and then 2 into 20 is going to be 10. I'm sorry, 2 into 2 should be 1. I just put a 2 right there. I apologize. So 1. So 1 over 10. Again, not a fraction, but we're going to check the 2 over 7. 7 is prime, and 2 is even. So that's not going to get any better. Now, these guys are going to fall out, and you're going to have your double set of parentheses still, because we are factoring. And it's x, or 1x plus 10, and then 2x plus 7, because these guys just fell down to make our second set of parentheses. So the left side's the first, right side is the second. Again, that is your factored form, so that's not solving. This is just factored. So if it says factor the quadratic, you're done. If it says solve, we need to set both of those equal to 0 and keep boogieing. For the sake of time and not trying to keep you over, we're going to keep moving, because hopefully we understand how to solve those simple binomials at this point. If not, we will do more later. All right, so looking at this guy again, we're going to draw our big star, or snowflake, or asterisk, whichever word you want to call it. AC goes on top, so A times C, B goes on the bottom, AX, AX. And you can skip writing that part. I'm just writing it right now so you can see what we're doing and where things are coming from. So for number 8, what is the A value? Somebody tell me what A is in that equation. Yes. B value. What is the B value? Good. And our C value, positive 16. Yeah, good, 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 good. Positive 16 for Z. Now make sure you're paying attention to that B value is negative. That means one of my factors have to be negative. And that's the same as when we were doing it with just the diamond method. So A times C, so 16 times 3 is 48. B value is negative 16. 3x, 3x. Now we're looking for the two numbers I can multiply together to get 48 that will add or subtract to get 16. So I'm going to take 48 divided by x, second graph. So I see that I have 2 and 24, 3 and 16, 4 and 12, and so on and so forth. So we're going to keep going, 6 and 8, and then 8 and 6 again, so we know we're done. 4 and 12 is going to be our easiest way to get to 16. So we're going to have 4 and 12. They multiply to give me a positive, but they add to give me a negative. So we have to make sure that we get a negative here. So it's going to be minus, minus. It's the only way to get to that negative 16. So we're going to look at our not fraction. 3 over negative 12. Can I reduce 3 over negative 12? What common factor do 3 and 12 have? 3 and 12 both have the common factor of close, 3. Yeah. I'm going to divide 3 by 3 and I get 1. And I'm going to divide that negative 12 by 3 and I'm going to get a negative 4. Don't forget about my x, because again, it's not actually a fraction. Nothing actually goes away. We're just sort of treating it using a skill that we already knew from fractions. If I check my 3 over negative 4, so again, looking at this not fraction to see if I can reduce this guy. 3 is prime, so it's not reducible. So then it's going to fall down into our double set of parentheses. The guy on the top goes in the front, guy on the bottom goes in the back, guy on the top goes in the front, guy on the bottom goes in the back. Now, probably, ideally, this is going to be calculator active. So we now have our factored form. If you take the equation given and put it in Desmos in the first line, and you put the equation factored form in the second line, they should graph directly on top of each other. So it should look like when you're done with it, once you put them both in, that you only have one graph. And that lets you know you did it right. Because I know a lot of students struggle a little bit with the positives and negatives. So it's not a bad idea, especially on an EOC or on a quiz or something of a big grade, to go check it and make sure it's right. Because it could be something as small as like positive negatives or something as easy as that. Usually finding the numbers for most of you is not difficult. It's just the plus and the minus and the factors where we get a little confused. But you can catch your mistakes if you use Desmos to check. Or multiply them back together by FOIL, distribution, or box method also works. All right, we're going to do another one. Those are such big numbers. Actually, what I'm going to do is show it to you when A is 1. So you can see that what we're doing up there works for every one of them because I only got 4 minutes left in class. All right, so A times C goes to the top. What's our A value for number 11? 1. Yep. What's my C value? Haha, tricked you. What's C value? Yep, 24. What's our B value? Yes, negative 11. So it's A times C at the top, so 1 times 24. B values at the bottom, so negative 11, and then 1 times x, 1 times x. So A times x, right? Now we're looking for what numbers we multiplied together to get 24 that will add or subtract to give me 11. So if you didn't have your calculator, 24 is a fairly easy number to maybe go through. 4 and 24, 2 and 12, 3 and 8. 9 is no good. 10 is no good. 11 is no good. 3, 4. I could do 4. 4 and 6. And then we hit 6 again. I don't know why I skipped 4. Sorry. So 1 and 24 is never going to give me 11. 2 and 12 can't give me 11. It's either 14 or 10. 8 and 3 looks good for 11. 4 and 6 gives me a 10 or a 2. So we're going to use our 8 and 3. 24 is positive, negative 11 is negative. So my 8 and 3 need to both be negative. I need to owe you 8 and owe you 3 to have to owe you 11. And remember, multiplying two negatives are going to multiply to a positive. You still look at this not fraction and decide if you can reduce it. The cool part when A is 1, if you use this process, and the only reason I would say do that is just so you have one singular process that you can practice over and over and over every time you have a trinomial. It's never going to reduce because there's a 1 on top, and 1 doesn't get any neater than 1. So it's going to be 1x minus 8 and x minus 3. And you've now factored it from the two sides of your big star, asterisk, snowflake, whatever you choose to call it. Can somebody tell me, I'm going to wait for just a second, what the solutions to this, because remember, that's our factors. So these are our factors. So if I push it down and go into solutions, I'm going to set them both equal to 0 and solve. And what are my solutions going to be? Jakaya, come on, you got me. You can do this one, right? Taylor, let me know what these are. X minus 8. Yeah, good job, Abby. Absolutely. So positive 3, positive 8 are the solutions. That's where it's going to cross the x-axis. That's also called the roots and the zeros and the solutions. So 3 and 8. We got 1 minute, but I'm going to do one more because, like I said, this is so important, so important. Again, just showing you that you can do it when A is 1 or A is not 1. So in the case of number 12, A is going to be 1, B is going to be a negative 10, and C is going to be 21. A times C is going to be 21 because it's 1 times 21. Our B value goes in the basement at the bottom. AX, AX. So it's 1x, 1x. So what did I multiply to get 21? That will add or subtract to get 10. I'm going to give it a minute to see if any of you guys can tell me. What did I multiply together that might give me 21? That will add or subtract to give me 10. Really good. Really, really good. So it is definitely 7 and 3. And then it is definitely a negative and a negative. When B is negative, the largest number, so if we just said 7 and 3 and then try to decide which it should be negative, 7 is always larger than 3 when they're positive, so that one will have to be negative. If B is negative, the larger of the two terms will always be negative. So now again, just so we know our steps, make sure this cannot be reduced. There's a 1 on top, so it can't. So it's going to be x minus 7. And then make sure this one cannot be reduced, and that's going to be x minus 3. And then that's our factored form. The x minus 7, if it just said factored, we're done. But let's go ahead and push it and see what are the solutions. So x minus 7 equals 0, and x minus 3 equals 0. So x minus 7 equals 0, x minus 3 equals 0. Add that 7, so x equals 7, and we added because it was negative. Yep, move that 3, x equals 3. So 7 and 3. Now be careful, because I know a lot of people start getting, because we factor in math 1 level, we factor more when a is 1. So it's not always going to be like just jump the opposite. So like back up here, if we solve this, this is not going to be a positive 4, because 3x minus 4 equals 0. We have more going on than just to move the 4. That would give me that 3x equals a positive 4, divide by 3, x equals 4 over 3. So be very careful, just because I've watched students get really comfortable and just be like, oh, it's 4. Oh, it's whatever the number is in the back, just opposite of the symbol in front. When a is 1, that's correct. When a is not 1, you actually do have to solve it. And I can't say enough to GCF, GCF, GCF. I made this worksheet without one, but you do want to check and see if there's a greatest common factor in your trinomials as well. All right, guys, I'm 2 minutes over. You're awesome. Maybe I'll see some of you this afternoon at the EOC boot camp. Otherwise, have a fantastic day and an even better weekend if I don't get to see you at tutoring, guys.